Okay, now we're going to continue on with some permutations, and this is going to be permutations of letters that are in words. Find the number of unique permutations or arrangements, because remember a permutation is an arrangement of the letters in each word. And so we're going to look at number 12, and then we're going to go and we're going to do number 15, geometry. Now, if you notice, police is the first word. There are no repeated letters. Okay, so I really want to do the number of permutations of those letters. And when we do these arrangements, we don't have to form words. Just how many different orders of the letters in the words could you have? How many different arrangements? So it's the number, and notice there is 6 total letters. So it's the number of permutations. 6, arrange all 6. Now, if you use the formula, that would be 6 factorial all over 0 factorial, because I would do 6 minus 6. Now remember, that's 6 factorial over 1, or 6 times 5 times 4 times 3 times 2 times 1. And that would be 30, 120, 360 would be 720. Now, you can also do it this way. You can just think of it as, if there's no repeat letters, I could also use my counting principle. Now, with repeat letters, it looks a little different. So I say, how many letters could I put in the first spot? 6. Then I could put 5 in the second spot, 4, 3, 2, 1, and I multiply them together. Notice that's what I did right here. Okay. Now, that works when there's no repeat letters. All right. Now, if you look at 15, which is the next one we're going to do, we have geometry. And you need to notice that I have repeated E's here. Okay? So, in geometry, I have 8 letters. So, if I think about it, it would be really 8 factorial, or 8 times 7 times 6 times 5. So I would do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so it's 8 factorial. But anytime you have repeated letters, the E repeats twice, so I have to divide by 2 factorial. Let's say there were 3 E's in that word. You'd have to divide by 3 factorial. Let's say you had E repeated twice, and you had another letter repeated twice, you'd have to divide by 2 factorial and another 2 factorial on the bottom. So that's how you deal with repeated letters. Now, if you notice, 2 factorial is the same as 2 times 1. So really, the 2 times 1 cancels out. And I really have 8 times 7 times 6 times 5 times 4 times 3 left. And if you do that on the calculator, you should get 20,160. So there's 20,160 arrangements of those 8 letters in the word geometry. And again, we've got to take care of repeated letters when you have them.